So if I look at this first guy and I write it in set builder notation. In set builder notation, I am talking about the domain of f of x. I'm going to write it out, but obviously, math person, I don't want you to write this many things. That's too much. You could just write d equals, but since we have two functions. Set builder notation, all right? Looks like this. You would say x. That's what I'm talking about. Such that x does not equal negative 11 over 2. And most of the time, you'll have this little guy here. X is an element of real numbers, all right? I think the assumption for this particular chapter is that it is a real number. When we get into imaginary, they will ask for a little bit more detail because they don't have the x as an element of real numbers. But I want you to know what that means if you were to see it on like a standardized test or a PSAT or SAT or something like that. All right. You do not have to write the element of real numbers at this point, but just so you know what that looks like if you were to test somewhere. They're just saying all real numbers except this guy is basically what that's saying. The other way they wanted you to write this was interval notation. So interval notation, you start with the assumption it's negative infinity to positive infinity. And then what's my limitation? In this case, just one number from negative infinity to positive infinity is my limitation. So if I were to write the same thing but in interval notation, I would go from negative infinity to negative 11 halves, union with negative 11 halves to positive infinity. Which would you prefer for this one? Assuming that you did it this way, I would actually do set builder notation for this guy, right? That's the one I would do it for. All right, let's look at the next one. For g of x, my limitation here is that I can't have a negative. So that means 6 minus x must be greater than or equal to 0, which means that x must be what? Less than or equal to 6, right? Anything bigger than 6 is going to give me a negative. All right, so for my domain of g of x, I would say for set builder notation, x such that x has to be less than or equal to 6, right? For interval notation, I am going to go where? Negative infinity all the way up to 6, right? So I would just say negative infinity all the way up to 6 inclusive. Which way would you want to do this guy? Yeah, I would do interval in this one, right? Make sense as to why one would be easier than the other at times? All right, so linear functions. The graph of a linear function is a line, hence the term linear function, right? It's pretty straightforward. We are used to the y equals mx plus b format, which is how this particular guy is written here. F of x is just my y, 1/2 x plus 3. M, my slope is 1/2. 3, that is my b or my y-intercept. Basically, you're just walking up the line. Rise over run, your slope does not change. That's why it's a linear, all right? And so you'll notice they plugged in -4, -2, +2, +4, and they get these points. But all you need is 2, because any 2 points form a line, which we learned in geometry. And once you have 2 points, you have the line. And every other point should fall on that line because it is the linear function. This is the way they graphed it, but the other way to graph it is what you've always known. Go straight to that 3, which is my y-intercept, and then go up 1 over 2, and you get that second point. All right, linear functions. The first thing you learn is rise over run. How far up do you go compared to how far over do you go? The triangle, if you've had chemistry, triangle means what? So delta y over delta x means how is my y changing over how is my x changing. The most familiar definition is the last one, y2 minus y1 over x2 minus x1. All right, that is what we have done since Algebra 1. So they've given me 2 points. They want me to find the slope. We're just going to plug it in. If you want to label it, you can. Your first set of points, x1, y1. Your second set of points, x2, y2. y2 minus y1, that's 5 minus 2. over x2 minus x1, 4 minus a negative 2. Biggest problem that we have with slope are positives and negatives. 5 minus 2 is simple. That is a 3. 4 minus a negative 2. Don't forget, minus a negative is plus a positive, so that is 6. My slope is 1/2. All right? Yes? So when I'm doing a graph, I want to start, this is if it's in slope-intercept form, I want to start at my y-intercept, and I want to move up or down, left or right, depending on what it is given me. All right? You don't need 3 points to do it. 2 points is enough. You only need 2. It is infinite, so you have your arrows at the end to indicate that you have an infinite line, because lines are by definition infinite. So they refer to this as general linear form. You'll see it in your book, right under example 2. You will also see this called standard form. Standard form is when you have your x's and y's on the left side, your c on the right side. It is typically all integers, okay? And a is usually positive, so they'll usually negate that a to get it positive. It'll be a positive a b, and a c, and all of them are integers, no fractions typically when it's in standard form. A few things to point out. Usually when it's in standard form, it's easier to graph using your intercepts. So they make a point to show you how it always works out. If I am looking for my x-intercept, you make the y a 0, which zeroes out the b. So you end up with just c over a. That is your x-intercept. Like by the time you solve it, you've zeroed this guy out and you're just dividing by your coefficient of x, right? So your x-intercept is just going to be c over a, which means your y-intercept is just going to be c over b, right? I mean, that's how it works if you were to zero out your a. And then your slope is going to be negative b over a. So negative a over b is your slope, because that's what's going to happen when you divide it out. So if I were to move this to slope-intercept form, I would move my a over, which is going to negate whatever it was, and I'm going to divide by my b if I were to put it in slope-intercept form. So if I'm looking for x-intercept c over a, y-intercept is going to be c over b, and slope is going to be negative a over b, always when it's in your standard form. All right? And so if we look at this example, find the intercepts and the slope, and then graph the equation. All right, so if I want to find my x-intercept, let's say I want to find my x-intercept here, I can just say c over a. What is my c? Example 3 in your books. What is your c? 9. What is my a? 2. If I want to do my y-intercept, I can say c over b. So I'm going to say 9 over negative 3. That reduces. What is my y-intercept? 9 divided by 3 is 3. And then my slope. They also want slope. Slope is going to be negative a over b. Negative a is going to be a negative 2. B is a negative 3. That is going to be positive 2/3. All right, so you can very quickly find your intercepts and your slope using those shortcuts. All right, you zero out one and find the other. Slope is always going to be what happens when you move your a over and divide by your b. All right, graphing. 2 ways to graph here. I have 2 points. I have where it crosses the x-axis and where it crosses the y-axis. I can do that. Or I have my y-intercept and my slope, right? So really when I have these 3 pieces, I can graph a multitude of ways. If I want to put in my intercepts, I'm going to say negative 3 for my y, 9 halves is going to be what, 4.5 around here. And I can connect those two dots, or I can say -3 and a slope of 2/3, and you're going to see up 2 over 3 is also going to fall in that same line, right? Anytime you have 2 points, you can just go ahead and graph it. So whichever way you want to do it, graph your intercepts or y-intercept and slope, because you already figured out that as well. They're both, everything's going to be on that line because it is a linear graph. All right, question. Point slope form. So this is usually a form of a line that you use to get to something else, okay? Very rarely will they want the answer in point slope form. I mean, unless it's just, like, again, a standardized test and they want to see if you actually know that's a form of a line. Most of the time, your answers are going to be slope, intercept, or standard form, right? Point slope is usually getting you to another place. You have the point, you have the slope, you're trying to find an equation of the line. And so this formula is actually, this form of the line actually comes from your slope formula. You'll see that your slope is y minus y1, x minus x1. And if you multiply both sides by that x minus x1, you're going to be left with y minus y1 by itself equals m times x minus x1. And this is your point slope. So this formula here is the point slope form of a line. Okay, and so if it'll let me move it over, point slope, y minus y1 equals m times x minus x1. And typically you will use that in this type of question. All right, so it says write the slope intercept. What is slope intercept? Well, slope intercept is y equals mx plus b, right? But they didn't give you your slope and your y-intercept. And so they're saying, give us the slope intercept, but we're going to give you 2 points. And one of those points is not your y-intercept. And so you need to find your slope first, and then you need to use your point slope to get your equation in the form that they actually want it. So the first thing you want to do here when you have points like this is you want to find your slope. And again, you can label this guy x1, y1, x2, y2. But we do want to find our slope first. So we have y2 minus y1 over x2 minus x1. My slope is -7/2. All right. Once I have my slope, I can use either of the points in point slope. It actually doesn't matter which one I use. I would probably use the ones that are both positive so that I'm not worried about minus and negative here, but either way, it doesn't matter. So if I said, plugging it back into this guy, I leave my y as a variable, minus, and I'm just going to use this. My y1 was 6 equals my slope, m, and then x minus my x1 was 1. All right? Is this in the form that they want it? No, this is point slope. What do they want? They want this guy, which means I need y by myself, okay? And so to get y by itself, I'm going to distribute and then move that 6 over. So I have y minus 6 equals -7/2. X, negative gives me a +7/2, right? I'm going to add my 6, gives me my y. When I add 6 over 1, that's 12 over 2. Right? I just got a common denominator. All right, so I have -7/2 x plus 19/2. Please leave it as 19/2. Don't give me a mixed number there. All right, and that's your y equals mx plus b. Now, if you were to graph that thing, you may want to figure out what it is as a mixed number so you know where to graph it. But in the form itself, leave it as an improper fraction, as long as you can't reduce it. So let's quickly talk about the little tip here. Don't confuse the zero slope of a horizontal with the undefined slope of a vertical. Because if you have a parallel line to a vertical or a horizontal, it's going to look different than a parallel line to something that has a non-vertical or horizontal. So, vertical, these guys, those are x equals something. All right, if x equals a number, you get a vertical line, and your slope is undefined, okay? If it is a zero slope, those are horizontal lines. They go this way, okay? Which means y equals a number, all right? And so your equations will look differently for a vertical and horizontal line. Don't confuse them. Vertical is when x equals something that is undefined. Horizontal is when y equals something and that is 0, okay? For every other line, you're going to see them that look like this. Y equals mx plus b are standard form. And they're going to say, give me a parallel or a perpendicular line. Just a refresher. If it is parallel, they will have the same slope. Parallel to non-vertical lines, notice it says non-vertical lines, are parallel if and only if they have equal slopes. Equal slopes. Two non-vertical lines are perpendicular. The only way to get a product of -1 is it's a negative reciprocal, okay? Because if you multiply a number and it's reciprocal, you're going to get 1, right? 2/3 times 3/2 is 1. 1/2 times 2 is 1. Anytime you multiply reciprocals, you get 1. In this case, you want -1. So they need to be reciprocals and they need to be opposites, one positive, one negative, all right? So there's no way two positive slopes can be perpendicular. There's no way two negative slopes can be perpendicular. That's not possible. One has to be positive and one has to be negative, and they need to be reciprocals of each other. That is perpendicular, okay? So it wants me to write the equation of the line in slope-intercept form. The first one, they want it parallel to this particular line. So let's look at this. What form did they give us this line in? What form is 2x plus 3y? That is standard. I have an easy way to get my slope. What is my easy shortcut to get slope when it's in standard form? My slope is what? -a over b, right? So it's -2 over 3. That is all I need from that line. I don't care about anything else from that line. If they are asking parallel perpendicular to a line, the line it is parallel or perpendicular to, you only care about the slope. I do not care about anything else with that line, okay? I have found the slope, that's all I need. Now they want a line that is parallel to this line, which means I'm going to use this slope, okay? And they have given me a point. So I have the slope and a point. What am I going to use? Point slope, right? So through this point, y minus y1 equals m.
Sorry, could you say that again?
I'm trying. M x minus x1. Siri wants to learn algebra 2. All right. I'm not done. They want it in slope intercept, right? So I have to do exactly what I did before. I'm going to have, this is y plus 2. We're going to do it quickly. -2/3. This is plus 2. That's a 3. That's not a very pretty 3, but it's a 3. 2/3 x. It's not letting me write. -2/3 x. This is plus a positive, right? Times a negative. So I'm going to have -4/3. Then what am I going to do? Subtract my, oh, that should have been a 1. That should have been a 1. Sorry, I read it wrong. It's 1, 2. All right, add my 1 over, or subtract it rather. So I'm going to subtract a 3/3. I get y equals -2/3 x minus 7/3. I have answered the question. It is the same slope, which means it's parallel. It is in slope-intercept form. I have answered my question. All right, that is parallel. The next question says perpendicular. All right, so my very next one says I want perpendicular. Now this line they gave me in what form? Slope-intercept. So I don't have to solve for my slope. They just handed it to me on a silver platter here, but it is perpendicular. So the slope of this line is what? What is the slope of the original line? So my original line has a slope of 3/4. Perpendicular means I need to do what? So my new line is going to have a slope of what? Yeah, I need to flip it and I need to change the sign. And then I am going to do exactly what I did before with this point. Y minus, what is my y value? -2 equals m, the value of my perpendicular line for the slope is -4/3, x minus 3. Minus a minus, that's plus. Distribute -4/3. Negative is positive, my 3's cancel. And then I can subtract my 2 over. So I'm going to get y equals -4/3 x plus 2. All right? And I've answered the question. It is in slope-intercept form, and it is perpendicular, negative reciprocals. Okay, these are also formulas that hopefully you can do in your sleep. The distance formula is actually based off your slope, okay? It is actually based off the Pythagorean Theorem, which is also what slope's based off of. So Pythagorean Theorem is a squared plus b squared equals c squared. All right, if you do that in triangulation on a graph, on a coordinate plane, right? It is your that's how you get your y2 minus y1 over your x2 minus x1, right? And that's also how you find your hypotenuse of the triangle that you create on a coordinate plane. And so your distance formula is the square root of the difference between your x's squared plus the difference between your y squared. So hopefully you know this distance formula, but if you don't, now would be a good time to start memorizing it. Square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. That is your distance formula. Your midpoint's much easier. Add your x's, divide by 2. Add your y's, divide by 2. Okay? So given any 2 points, you should be able to find the distance between them and the midpoint of the segment that's created by those. All right? And you literally just plug it in. So for distance, I am going to subtract my x's, -3 minus 2, and I'm going to square it. And then I'm going to subtract my y, 7 minus a -4, and square that. -3 minus 2 is -5. -5, when I square it, gives me what? 25. 7 minus a -4 is 11. Squared is 121. Square root of 146 does not have a perfect root. We're just going to leave him like that. That is my distance. That's how long the line segment is that's created by those two guys. And then if I wanted my midpoint, I am going to add negative 3 plus 2 over 2, 7 plus negative 4 over 2, right? Negative 3 plus 2 is negative 1. Just leave it as a fraction. 7 plus a negative 4 is 3. Leave it as a fraction. That is my midpoint. So it's just a matter of knowing those. Hopefully you know those, right? Forms of linear equations, you have your general or your standard form, you have your point slope, and you have your slope intercept, and then you have some definitions. Your slope definition is technically y2 minus y1 over x2 minus x1. Parallel lines have the same slope. Perpendicular lines have negative reciprocals. Homework. Page 15, 4, 6, 10, 14, 22, and 26.